So this is, the next presenter will be also online, and this is Armand. Connectivity of a crossroads evaluating urban green spaces and linear infrastructure effects on tiger conservation in Bangalore City, India. So,
Hello, is I'm audible?
could you
Hello,
repeat that?
is I'm audible to you? Okay, can I share the screen?
Yes, please share your screen.
Okay, I'm ready. So we have total 7 minutes.
Yes, you have 7 minutes and 1 minute for questions.
Okay, so my name is Anam, and I'm a master's student in University of Missouri, Columbia. I'm also working on tigers in India, but this is my friend's project who is working on urban tiger conservation in India. So this is his project, and this is his idea how to work on the tigers in the urban landscape. So total is like India. You can see the map. This is the central India. That is the state of Madhya Pradesh, and this is a city called Bhopal city, adjacent to the tiger reserve. So these are all the urban green spaces that is like occupied with the tigers and the other species. So there is no significant study so far has been done on the tigers in the urban landscape. This is going to be the first kind of study. So we identified total 535 patches in the urban landscape, and we surveyed them like you for 5 to 6 years. And just we encountered that out of 112 grids we surveyed, we found that 78 grids were recorded with the tiger presence using the science surveys and camera trap data analysis. And yes, he is that person who is the um, project investigator behind this project. And these were studies we find like tigers are moving in around the urban landscape using the roads and other urban spaces around the cities. So this is what make us curious to know about what exactly the tiger movements are going in the landscape and how the landscape is occupied with different habitats with the tiger occupancy and detection probabilities. So this is a rural urban gradient. We consider the city and you can see the contrast between the cities and the urban spaces where tigers are living in this landscape. So the main objective of this study is to find the occupancy and detection in urban green spaces of Bhopal using occupancy modeling and habitat connectivity of the patches. So first we did is like we mapped the land use land cover map using the maximum likelihood classification scheme, and then we identified the urban green spaces around the city's patches, and then we quantify the habitat connectivity using the graph theory based landscape connectivity modeling using the graph F and the R model. And then we finally estimated the tiger occupancy, considering that the grids are occupied with the constant of tiger presence unit as 1, and we occupied the tiger conservancy. This is our whole methodology, like the data collection from the ground, then LULC, then habitat suitability modeling, and then we extract the suitable patches for the tigers, and then we run the graph theory for seeing the functional connectivity of the habitats, and then we run the game theory equations to see the tiger movements across different grids in the landscape, and then we run the occupancy estimation. This is like the results, and this is the habitat suitability modeling result for the green species. The red ones are like the highest suitable patches in and around the city boundaries, and these is the connectivity. We found how the connections are going with the landscape among the different suitable habitats. And then we run the game theory where we consider tiger as a player 1 and where he is playing with the player 2 habitat or the management affecting especially the urban green spaces. And we run the hawk and dove game. So hawk and worsening high cost for both the habitat degradation and stress. This is the payoffs we give upon basis of the field analysis. And then hawk and dove, the wind game, like dove loses, tiger gets marginal habitats degraded. Even though the habitats and the corridors are decreasing, the tiger occupancy and the distribution is constant over the landscape. So we share that there is a coexistent and stable habitat balanced use in this model. And this is the corridors of the city landscape we found. And we found that even in the lowest connectivity and the stressful conditions, tiger are moving and occupying the landscape with a much more coexistence habitat and model level. And this is the game theory result. We predicted that the dynamic equilibrium, how the tigers are moving and using the landscape, even under the stressful conditions of the anthropogenic pressures like the roads and the villages and the other urban spaces around the landscape. And then this is the occupancy results we did for using occupancy for the forest, non-forest areas, patch size, and the connectivity. So, and considering the road density as a detection of probability influence factor in all the models, and then we run 6 different models for the occupancy estimation, and we found that the model number second, with all the parameters, with confidence interval more than 95% influencing the occupancy of the tigers in the landscape under the road detection probability. And these are the results for the model for the occupancy. And we found that the non-forest area is like there is a decreasing of occupancy as the non-forest percentage is increasing in the grids. But when the patch size is increasing, the occupancy of the tigers is constantly increasing. And for the forest, where there is a 100% forest percent in the grid, we found the occupancy of the tigers is high versus the grids where there is no forest at all. And when we see occupancy by connectivity, we see the lowest and the medium connectivity, higher patches shows the occupancy is good. This means like even in the degraded corridors and the less connected corridors, tigers are occupied with the landscape in this stressful situation. So what is the total? We found that when the road detection density of the roads are increasing, we found the probability of tigers in increasing. This indicates that tiger is using the landscape across the linear structures, and they are moving across the landscape without any conflicts in the landscape. So to overall the detection of the say that intercept of the 70% detection, yes, highly detectability baseline is there, and forest shows a positive occupancy influence and non-forest is a negative. Pest size shows the positive. Largest pest size shows the larger occupancy. And connectivity, among the connectivity, medium connectivity patches shows the positive influence on the occupancy, although it is not significant, but this is help in the occupancy. And the road density shows slightly positive, but not a significant. So no strong detection effect on detection, but yes, it's a strong positive detection element. Thank you. This is our site, and these are the funding partners. You can reach us out to contact us on this.
Thank you very much for your presentation. I wonder if you have ideas about why road density didn't have a strong effect. Is road density just high throughout the region?
Her question was why you think road density did not have a strong effect, and if maybe it's just because it's consistently high throughout the region.
It's a positive effect and this non-detection because tigers may be occupied with the forest landscape, but they're not like occupied with the regions where there is roads or more, but they are moving through the landscape. That shows like the detectability is high, but the occupancy is less for the road density.
Okay, thank you very much.